Now, the question number 9, the complete combustion of 2 moles of an alkane produces 400 dm³ of carbon dioxide measured at 301 kelvins. So remember, now this is a moles question where you can't use that thing that you use in O levels. 1 mole is equal to 24 dm³. Okay, a gas is not going to occupy this volume if the pressure, if the temperature is 301 kelvins. It's not going to happen. So carbon dioxide can be assumed to behave as an ideal gas under these conditions. What is the formula of the alkane? So they're asking for the formula of the alkane. Now the first thing is we need to figure out the moles of carbon dioxide. So I'm going to use PV is equal to nRT. That's the ideal gas equation, where pressure is, I mean, basically it is that temperature is proportional to volume, temperature is proportional to pressure, and moles uh, is also, I mean, it links moles, temperature, volume, and pressure together. Pressure should be in pascals. So it's 1 times 10 power 5. Remember, the units have to be, you have to be very careful with the units. The volume must be in, not in dm cube, it should be in meter cube. Now to convert dm cube to meter cube, remember this conversion that from cm cube to dm cube and from dm cube to meter cube. If you want to convert things, you divide by 1000 each time. So at the moment, your value is given in dm cube, so it should be 400 divided by 1000. So it's going to be 400 into 10 power minus 3. The moles are unknown, so that's unknown. Uh, I'm going to divide it by RT. The temperature must be in kelvins. In this case, we are lucky that it is already in kelvins. If it's not, if it's given in centigrade, what you're going to do is you're going to divide, you're going to add 273 to it. And what is R? R is 8.31. That is the gas constant. So I'm going to try and find this value. Anyone has a calculator? Try and tell me what the answer is for this. 1 times 10 power 5 into 400 10 power minus 3. That gives me 40,000. 40,000 is going to be divided by, somebody should also try it. Okay, 40,000 is going to be divided by 300. So that gives me 133.3, and it's going to be divided again by 8.31. So the final answer is around 16. So moles, carbon dioxide moles are coming out to be approximately 16. So what he's saying is that there's 2 moles of an alkane. It has to be an alkane, uh, which, and all of them are alkanes. So the ratio is that you have an alkane and it is 2 moles, and that alkane burns and produces carbon dioxide, and the carbon dioxide moles should be 16 moles. So it's basically 1 ratio. It's going to be 1 ratio 8. Uh, so it's going to be 1 ratio 8. So the answer to this is going to be the first one. That one alkane is going to produce, it's going to be producing 8 carbon dioxide molecules. And the only way it can produce one molecule of alkane can only produce 8 carbon dioxide molecules if it has 8 carbons in the formula. So the answer is definitely going to be A. Is that clear? Ibar, is this clear? Bazga, Ibrar, Abba, is this clear?
Yes,
Yes,
sir.
sir.
I said, next one, in which the action does an element undergo the largest change in oxidation number? You just need to find the oxidation state, and he's asking for the largest change. Very quickly, Mn over here is +7. You should know that MnO2 is +4. MnO4 minus, sorry, MnO4 minus 2 is actually +6. I think it is +6, yes. MnO4 minus 1 is +7. So that's probably a change of 2 or 3. Nee, it's probably a change of 2 and 1. This is Cr2O7 is +6. So it's undergoing a change of +3. I mean, there's a change of 3. Cl is 0 over here, Cl is +5 over here. So that's a significant change. So probably this one is the correct one. On the other one, Cl is 0. and Cl over here is +1 and -1. So it's probably B. I think it's B. I mean, that's the largest change in oxidation state that's happening. You can do the calculation. Oxygen is -6, -2, -2, -2, that's -6. And there has to be one Cl with +5. So only then would you get -1. Next question is about equilibrium constant, and they're saying that PCl5 decomposes and there's this reaction happening. Uh, and you have to find the value of Kc. Now, for this, you usually make a table that is PCl5 in equilibrium with PCl3 and Cl2. All of them are 1 mole each. The first thing is you write initial moles. What is the initial quantity that is added into the system? Uh, the way that you're going to add that is that you have 1 mole of PCl3, 1 mole of Cl2, and 1 mole. All of them are 1 mole. So 1 mole are added into the container. Those are your initial moles. So all of them are 1 mole. And they are placed in a container. So you're placing them in a container, and when you place them in a container of volume 1 dm cube at 250 centigrade and allowed to reach equilibrium, the equilibrium mixture contains 1.8 moles of PCl3. So the next thing is you write your equilibrium moles. So at the bottom you write your equilibrium moles, and they're saying that the mixture contains 1.8 moles of PCl3. So what does that mean? It means that you started off with 1 mole. You started off with 1 mole over here, and now you have 1.8 moles. So that means an extra 0.8 moles got produced, right? There were extra 0.8 moles getting produced. And since PCl3 and Cl2 are 1:1, Asha, can you see my pointer? Uh, Ibrar, you can see my pointer, right? चलो ठीक है.
Yes, sir.
अच्छा. अच्छा, so you started off with 1 mole and now you have 1.8 moles, which means 0.8 moles got produced. And if 0.8 moles got produced of PCl3, then Cl2 is right next to it. It's also going to get produced. And it's 1:1. So 0.8 of this would also be produced. So your moles of Cl2 would be 1.8 as well. Why? Because they were also initially 1 moles and 0.8 moles got produced, which means 1.8 moles. Now, to produce 0.8 moles of PCl3 or Cl2, 0.8 moles of PCl5, because it's 1:1, they must have reacted. And if they have reacted, that means they got used up. So you initially added 1 mole, 0.8 moles got used up. So you would be left with 0.2 moles. So these are your equilibrium moles. And now you can find the value of Kc. Kc is going to be products over reactants. It's going to be 1.8 times 1.8 divided by 0.2. The products and the reactants, they're all going to have a power of 1. It's going to be PCl3 concentration. And remember, you don't use moles. You always use concentration. But the thing is that over here, the container is given, the volume of the container is given as 1 dm cube. So if it's given as 1 dm cube, then it's pointless to divide. I mean, you can find concentration by dividing by 1. You're going to get the same thing. So it's 1.8 times 1.8, and you divide by 0.2, and the value that you get is 16.2. ठीक है. Ibrar, Aba, Basga, is this clear?
Yes, sir.
It's the next one. Uh, the fifth to eighth ionization energies of 4 elements are shown. Which row refers to chlorine? Now, chlorine, if you look at chlorine, chlorine has so chlorine has an inner shell, and so this is chlorine. I mean, the more shells, the outer shell has 7 electrons, and then you have your inner shell with 8, and then there's going to be another shell with two electrons in the middle. So where would the jump occur? I mean, removing which electron would become very difficult for chlorine. Like the first, second, third, fourth, fifth, sixth, and seventh, they would all be kind of easy because the electrons are very far away and they were shielded and they're in the outer shell. They're high energy as well. So it's easy to remove the seven electrons, the outermost. Removing the eighth electron is going to become very difficult. So there's going to be a drastic jump on removing the eighth electron. So Konsa, which one would be the answer?
C.
Okay, so it's going to be C. Removing the fifth, sixth, seventh is not really going to be difficult. But as soon as you move to the eighth, there's this huge jump, almost three times. So it's going to be C. And just to confirm, is there any other option where in the other options there is no jump? Okay, Rida, Hiba, is this clear? Abba, is this clear? As a next one. Magnesium nitrate decomposes when heated to give a white solid in a mixture of gases. One of the gases released is an oxide of nitrogen. Uh, so, I mean, this is a simple question that magnesium nitrate is undergoing decomposition. So it would form magnesium oxide plus NO2 plus half O2. So that's your balanced equation, and you're given that there's 7.4 grams of anhydrous, which means there is no water. So there's only magnesium nitrate, 7.4 grams. The MR of this is 124 plus 24. That's what N is 14, O is 16. So that's probably 148. So it's going to be 7.4. Yes, it is 148. It's going to be 7.4 divided by 148 mass divided by MR. That gives you 0.05 moles. And what are you asked in this question? What mass? He said one of the gases an oxide of X, which is a nitrogen. I mean, this is nitrogen oxide. He's asking for the mass of this thing. So the moles would be double, 0.1 moles, because it's 1:2. And NO2 is 46. 32 plus 14, that's 46. So it's going to be 0.1. So it should be 4.6 grams. Okay, so this was a relatively straightforward question. Now this one, which statement explains why iodine is less volatile than chlorine? What does volatility mean? Any idea?
The ease with which a substance evaporate.
Okay, so if a substance is volatile, it has low melting points, right? Low boiling points. Uh, which one is more volatile? He's saying is less volatile, which means it has high melting points or boiling points. Difficult to evaporate. And chlorine has low boiling points. Achha, without, I mean, ignore the options first. What's the explanation? Why does iodine have high boiling points?
Because it
What
is
is,
a bigger molecule,
huh?
which means it has more van der Waals forces.
Okay. I mean, and there is only just van der Waals forces because it's a non-polar
Exactly.
molecule. So apart from van der Waals forces, there is no other. So, uh, so the answer is going to
B.
be,
B.
I think it's going to be B, right?
Exactly.
The bigger molecule has more electrons, and there would be more temporary dipole-induced dipoles, which is van der Waals forces. Uh, Next one is ammonium carbonate is a crystalline solid on gentle warming. A reaction occurs forming ammonia. How are the carbonate ions behaving? What's happening? Ammonium carbonate is a on gentle warming. A reaction forms. So ammonium carbonate is this thing, right? It's this thing. On gentle warming, a reaction forming ammonia is one of the products. So there's some reaction that's happening. I don't know what the reaction is, but ammonia is one of the products. So there would be two ammonias getting produced, right? I said, just by looking at it, how are the carbonate ions behaving during this reaction? I mean, we don't know what the other product is, right? Uh, So to figure out how the carbonate ions are behaving, first figure out how are the ammonium ions behaving. Like you had ammonium ions, now you have NH3. What have they done?
They've they've accepted an electron. Nee,
Maybe.
Hydro
they've given a proton, so it's a
ठीक है.
base. Like acid.
ठीक है, so
Exactly.
they've actually lost an H plus one, so it's behaving as an acid, right?
Yes.
So what would the other thing be behaving as? It would obviously be behaving as a
Branch is a base and
uh,
exactly. Yes.
but we don't know because we don't know what's forming. ठीक है, we have no idea. They didn't tell us, right? So the remember acids and bases are always together because if something loses an H plus one, there must be another thing that accepts H plus one. So we knew that ammonium ions were behaving as an acid because they were losing H plus one ions or losing protons. So the carbonate ion must be behaving as a base, a conjugate, not a conjugate base, just a base. ठीक है. Abba, is this clear? Hiba, is this clear? Baza, clear?
Yes, sir.
I said this one is that one molecule of an oxide of element Z reacts with 6 molecules of water to produce an. So he's talking about oxides. Okay, of element Z. We don't know what element Z is. Let's start with, and they're reacting with water, right? First one, I mean, this is O levels. Will aluminum oxide react with water?
No.
Yes. Nee. Yeah.
No. Aluminum oxide is in. Well, I mean, you remember the layer of aluminum oxide, coating of aluminum oxide on top of aluminium. Okay, aluminum oxide it's insoluble. It doesn't react. That's the same. What about silicon oxide?
No, it won't.
It
Okay,
won't.
it's not going to react with. It's not going to react because this is sand. Sand doesn't react with water, right? So these two are definitely not going to react. What about phosphorus oxide, P4O10? Just a hunch. What would be formed? Like what would phosphorus oxide form with water? I mean, there's H coming in as well. Messy guess, girl. I mean, it should be very obvious.
Hydroxide.
Only phosphoric acid, H3PO4.
Okay.
But just put them all together. It's like H and P and O. So it's obviously H3PO4. Okay, so H3PO4 is going to be formed. And you can balance this, and there are 4 phosphoruses, there would 12 hydrogens, so there would be 6. So this is 6 molecules of water. So that's your answer, B. Is that clear?
Yes. So if sulfur reacts with water,
Not sulfur, the oxide of the element Z, right? So sulfur. What
yeah,
about sulfur? Let's say sulfur trioxide reacts with water. Guess karo, what's going to be formed?
sulfuric acid.
TKH2SO4 is going to be formed, and this is already balanced. So you would just need 1 water molecules. TK, बात clear है?
Acha, all right. So there are 6 molecules of water.
हाँ, क्योंकि they had specifically said that 6 molecules of water are going to react with it.
Mhm.
अच्छा, which property shows an increase from magnesium to barium? अच्छा, ionization energy. Would it become barium is a bigger Mg is right at the top and barium is right at the bottom of the group. So
It
ionization
becomes easier. It reduces.
it reduces bigger ion. It's
Yeah.
easier bigger atom. It's easier to remove electrons. It's going to be more shielded. The electron is going to be further away from the nucleus. So which is why it's going to become easier to remove electrons. So that is definitely wrong. So what is meant by oxidizing power? Ability to lose electrons or gain electrons?
Lose electrons.
ठीक है, ability to
Lose electrons.
lose electrons. So
So okay.
does it decrease or increase?
I guess barium is actually a bigger molecule.
just one. I'll come to this later about oxidizing power. Okay.
Hmm.
Peredo, just tell me who's going to lose electrons easily?
Uh,
Is it going?
Barium,
Okay, and why barium?
because it's a bigger molecule and it's away from the nucleus.
Yeah, it loses electrons easily. Okay,
Hmm.
it's a bigger atom, and so the electron is very far away, and the ionization energy is lesser, so it's easier for it to lose electrons. Okay. Hiba, is this clear? Bazga, Aba, is this clear?
Yes.
Acha, so we'll come to this later. What about the solubility of the hydroxides? Do you know the solubility table? Is
Yes,
magnesium
sir. It it increases down the road.
and it definitely increases. So that is the answer. C is the answer, right?
Yeah.
And solubility of the sulfates actually decreases. Magnesium sulfate is soluble, whereas barium sulfate is not soluble. So C is definitely the answer. What is oxidizing power? Remember, when you talk about oxidizing power, he's not talking about losing electrons. Oxidizing power means to oxidize the other substance, not to get oxidized yourself. Do you get the point? That if something has oxidizing power, they don't they don't mean to oxidize. Like if I have oxidizing power, I'll be oxidizing someone else. Okay? I wouldn't be losing electrons myself. So when you talk about oxidizing power, he's basically what he means is getting reduced and oxidizing the other substance. Okay? So I'm just going to clarify this and repeat this again. When we say that some substance has an oxidizing power, then that substance is the one that is oxidizing the other substance, not getting oxidized itself. Itself, it would be gaining electrons. Is that clear?
Yes.
Yes, sir.
So, so um, who's going to is like the oxidizing power would actually decrease, and the oxidizing power. When we talk about the oxidizing power, we won't be talking about the metals because metals always like to lose electrons. They don't like to gain electrons. When we talk about oxidizing power, we are talking about the oxidizing power of the ions. The ions are the ones that would gain electrons because the metal atoms they're never going to gain electrons. They're never going to gain electrons to form negative ions. They would always lose electrons. So when we talk about oxidizing power, we're not talking about the metal atoms. We're talking about the metal ions. The ions can possibly gain electrons back, right? And the smaller ion is the one that would be attracting electrons strongly. The bigger ion is not going to be attracting electrons strongly. Is that clear as well?
Yes, sir.
Yes.
Okay. So just remember, when they start talking about oxidizing power, things can get slightly confusing. Uh, and similarly with reducing power, when they talk about reducing power, they don't mean if something has a certain amount of reducing power, that doesn't mean it's getting reduced. That means it's getting oxidized. It's reducing the other substance. I said next, let's ignore this. Uh, Now we have organic. Okay, this is organic. Let's just go through this. We would probably not be able to do any of the questions right now. So I'm going to just continue with. I mean that's pretty much all the past paper right now without the organic that we would be able to do at the moment. Okay, just once again, I'm trying to open the board.
Sir, with organic, how much course is left with organic chemistry for us?
Right now,
Yes, exactly.
um, probably 2 weeks.
Because, acha. क्योंकि I was going through the syllabus, we've almost done everything. मतलब carbonyl compounds and halogen alkanes, alkenes.
We haven't done anything. We just did the naming part.
Acha, we still left with the entire topics that we did, but in a more matlab other part of it. Acha, acha,
We didn't do any of the things, okay? But we actually
acha,
most of it is left. Okay, just 1 second.
acha.
But we just did the introductory things. We did alkanes. Again, alkenes is much bigger.
Hmm.
So we're going to start with alkenes. I'm skipping. I'm just skipping to a few things in organic. Okay? Like the fractional distillation, there's nothing new in it. It's the same old. I mean, it's. अच्छा कहाँ पे थे हम यहाँ पे अच्छा so I'm just going to first go through what we were doing. We were talking about alkenes and we were talking about unsaturated hydrocarbons. So एक सेकंड रुकना ही मैं